Dr. D. Govardhan, Professor in Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today the topic is central gravity, centroid, the difference between centroid and central gravity. Central gravity, generally it is represented as CT. It is a point in which the whole of the body weight assumed to be passing through it. And the point is always remains constant irrespective of rotation of the body. The central gravity, the word it refers to, generally it is applicable to three-dimensional objects. The second one is centroid. It is a point through which the total entire area of the body assumed to be passing through it. Or in other words, it is applicable to only two-dimensional objects such as rectangle, sphere, triangle, quadrilateral, circle, and etc. The centroid is represented by G or C now. Center of mass. It is a point at which the entire mass of the body assumed to be concentrated through it. And the position of center of mass remains constant irrespective of rotation of the body. The center of mass and center of gravity both are treated as same point when the gravitational field is uniform. Hence, since we are considering localized area, for calculation point of view, the center of mass and center of gravity both are treated as same. In order to represent the position of center of gravity, centroid, or center of mass, it is required some reference lines. The reference lines generally taken as the line which is in horizontal passing through the bottom of the object is treated as x-axis. It is also treated as the horizontal reference line. And the vertical line which is passing through the extreme left of the object. But when the body is in symmetrical, the line which is passing through it, if it is symmetrical, that line is also taken as a reference line for determination of center of gravity, centroid, or center of mass. The methods for center of gravity. The same method is also applicable, which is using for center of gravity. It is also applicable for centroid as well as the center of mass. There are three methods are available. Geometrical considerations. The second one is method of movements. Third one is graphical method. But a graphical method is most tedious and cumbersome method. Hence, generally it is not at all discussed in this content. We are using only geometrical considerations as well as the method of movements for determination of center of gravity. The center of gravity of some geometrical consideration. Here a rectangle is given. For the rectangle, let B is representing, let H is representing height of the body. It is a two-dimensional figure we are taking. That is centroid only we are considering. Let x-axis and y-axis is representing the reference axis which are passing through the bottom of the figure and extreme left of it. The total area is given by the product of B into H. And the center of gravity or centroid, which is at a distance with respect to the y-axis, is given by B by 2. And with respect to the x, at half of H naught. That is the centroid is represented here now. where it is having coordinates of B, comma, of H now. That is B by 2, comma, H by 2 now. Similarly, the centroid for the triangle is which is having dimensions base is equal to B and height is equal to H. Here, in this case, the location of centroid with respect to the base is given by at H by 3 now. Similarly, when you are taking with respect to the other side also, when you are just combining that median, that is nothing but passing through midpoint to the opposite vertices. Again, in that height, the centroid is representing at a distance of H by 3 only. Similarly, if you take another one is also at the same positions. That is, it is this intersection of the medians of the triangles, which is at a distance of 1 by 3 into H, or it is also equal to H by 3. The area of the triangle is given by half into B into H now. And the location of centroid for the circle. The circle having a radius is equal to R. The area of the circle is given by pi r square. Since it is symmetrically with respect to the x-axis and y-axis, hence the intersection of the reference lines is treated as the position of the centroid. For the semicircle, the bottom diameter, the diameter that treated as the x-axis now. The symmetrical lines which is perpendicular to the x-axis is treated as the y-axis. Since the body is symmetrical with respect to the vertical lines, hence the x coordinate of the centroid is equal to 0 and y coordinate is given by 4r by 3 pi. For quarter circle, again assume r is representing the radius of the circle. Then the area of the circle becomes pi by 4 pi r square, pi by 4 r square. In this case, the x coordinate of the centroid is given by 4r by 3 pi and y coordinate is also equal to 4r by 3 pi. Centroid of ellipse. The area of the ellipse is given by pi into AB, where A is representing semi major axis length and B is representing semi minor axis length. Since the object is symmetrically with respect to the x-axis and y-axis, hence the intersection of x-axis and y-axis is treated as a position of the centroid. Hence, here we are considering the x coordinate is equal to 0 and y coordinate is also equal to 0. And for the solids, for the cylinder which is having the radius of the circle, area of the cross section is equal to pi r square, where r stands for the radius of the circle and L is equal to h is representing length of the cylinder. Then the volume of the cylinder is given by pi r square into h, that is the area of the base circle multiplied by the length of the cylinder. Then the center of gravity is located at the half of the length at position of G, that is that intersection of half of the length and the axis of the cylinder. The axis is nothing but the line which is passing through the center of the circle along its length. Similarly, for the sphere, the position of the centroid is given by its center, that is from the circumference at a distance of r. The volume is given by 4 by 3 pi r cube. Hemisphere, The position of the centroid is given by 3r by pi, and the volume is given by the shaft of the sphere, which is equal to 2 by 3 pi r cube. Right circular cone. The position of the centroid is given by h by 3, where h stands for the length of the axis of the cone. If r is the representing the radius of the base circle, then the volume of the cone is equal to 1 by 3 pi r square h. Similarly, for the pyramid, which is having the cross section of breadth b and height a, if h is representing that length of the pyramid axis, now the position of the centroid is given by h by 4, similar to the cone, and the volume is given by AB, that is the area of the cross section, into h by 3 now.
Like, share and subscribe. Hit the bell icon for more updates.